A body of mass m falls from rest through the air. A drag force, d is equal to bv squared, opposes the motion of the body. A. What is the initial downward acceleration of the body? B. After some time, the speed of the body approaches a constant value. What is this terminal speed, vt? C. What is the downward acceleration of the body when the velocity is equal to half the terminal velocity? So for A, let's draw a free body diagram. We know that there's a downward force due to gravity of mg and an upward force due to drag, which is equal to bv squared. In this case, b is just some constant based on the air and some material properties. Well, the initial velocity is when it's from rest, and when it's at rest, the speed is 0. So there actually is no drag force. Using Newton's second law, the acceleration is just the force divided by the mass, which is just g. It's not negative g because it's asking for the downward acceleration, so we just give plain g. For B, it's asking to find the terminal velocity. This basically means the object is at a constant velocity. But if it's at a constant velocity, there's no acceleration. And if there's no acceleration, there's also no net force. There will always be a downward force due to gravity. But how can we oppose this? Well, the only other force there is in this scenario is drag, which is equal to bv squared. For there to be a net force of 0, these two have to be equal to each other. G has to be equal to bv squared. In this case, this would actually be the terminal velocity. So all we do is solve for the terminal velocity, which is mg over b. So this is the terminal velocity. Next, for C, it's asking what is the force, or no, it's asking what is the downward acceleration of the body when it's half the terminal velocity. Well, half the terminal velocity is just, based on what we have here, mg divided by, not 2, but since it's inside the square root, 4b. Drawing a free body diagram once again, we have this downward force of mg and an upward force due to drag, which is equal to b v squared, but v is this vt over 2 squared. The downward acceleration is just, let's first actually find the downward force, which is mg minus, so this is going up, so it's negatively contributing, b times this vt over 2 is the square root of mg divided by 4b squared. The square root cancels and the b's also cancel. So this is just mg over 4, or also 3/4 mg. And again, by Newton's second law, we have that the downward acceleration is equal to the net force divided by the mass, so 3/4 g. And this is our answer.